Okay, the next section we're going to do is 9-4, and that is triangles. The majority of this should be a review. We'll add a little algebra to it with writing equations. I would try to write the equations. Doesn't mean you have to solve them algebraically. When we get into the other polygons and we're finding missing angles, you're going to be finding more than just an X or one missing side like this. So using an equation will be helpful. So you should have already watched the YouTube video that showed you why the three angles of a triangle add up to 180. So we now know that the sum of the measures of the angles of a triangle is 180, which should be review, I guess. You'll be given a triangle with a missing side, and these are supposed to add up to 180. Well, in the past, you probably would have just said this plus this equals whatever at 95, and then I'm going to subtract that from 180, and I'm going to get 85. Well, algebraically, because some of them will start to get more complex in the next chapter, I would like you to at least be able to write this as an equation to show that these three angles, 43, 52, and X, add up to 180. Now, whether or not you solve it like an equation, I'm okay with that right now, not having to do that. But I'd like you to get this step and then the answer at least. So at least write it as an equation. When you need to solve them algebraically, then you will, because you'll know how to set them up. But you don't have to show all these steps here. You can just type it all into the calculator as long as you would have this and this. That would be good practice for now. So this section has a little bit of vocabulary. When we do geometry, there's a lot of vocabulary to it. The first one is a line segment, and that's just part of a line containing two endpoints. So anytime that you need to stop to get the definitions written down or the examples, just pause it. So part of a line, just part of a line, and it containing two endpoints. So it could look like this. We've got A and B. And when you name it, you name by endpoints. So this would be line segment AB, and you'd put a little line above it. And so anytime we're naming the segments on any shape, we would name it with a line segment as well. So we're going over this because we're going to be naming sides of triangles and quadrilaterals in the future. A vertex is a common endpoint. So if I have my triangle here, any one of these would be vertices, which is plural for vertex. And if you were naming them, if they had letters, you would just name them by a capital letter. Now we're going to name or classify triangles, I should say, two ways. One way is going to be by the angles. So this is how we classify by angles: acute, obtuse, and right. And then there's three down here where we classify by sides. And so we're going to do them both at the same time. I don't know if in the past you've done them both at the same time or one at a time, but that's how we'll do those. So classifying by the angles. An acute triangle has to have all acute angles. Now we skipped angles. Acute angles we know are angles that are less than 90 degrees. So it's sometimes hard for me to draw these, but we'll just assume that this one is all acute and it's 30, 70, and 80 degrees. Notice all less than 90 degrees adding up to 180. That would make it acute. Obtuse can only have one obtuse angle. You can't physically make one with more than that. So we've got an obtuse triangle with 30, 40, and 110, and it adds up to 180 degrees. My right triangle has to have one right angle. You can't have more than one right angle in a triangle. It would be a square or a rectangle. So let's say that we had 35 degrees, 55, and 90. So there's my right angle, and that all adds up to 180. Just like this one here, here's my one obtuse angle. Now, before we go over the classifying sides, I'm going to talk about what congruent means. Congruent means same / equal. So you can see that something's equal a couple different ways. Sometimes they'll show you with little lines, and so if there's one hash mark and one hash mark, that means those two are supposed to be equal. You could have all three sides being equal, and that might be how they show it. They might show something being congruent with the little markings inside of the triangle to show that those two are equal to each other. So those markings can show congruence. They can also write the lengths or the angles inside. They could actually put 45 and 45, and you would know that those two angles are congruent because they're the same. All right, so now we're doing classification by sides. So a scalene triangle has no congruent sides. So we just make a triangle with no congruent sides. If there's no markings on it, no numbers on it, then they're not equal. You could also, sometimes they'll show a triangle with 3 different angle measures, and if the angle measures are all different, then it's going to be scalene, okay? So if I was looking at this one up here, see how all 3 of the angle measures are different? That means all the sides are different as well. All 3 of these would be considered scalene, as well as acute, obtuse, or right, because they have all different angle measures, and if they have different angle measures, that means all the sides are different too. Now on an isosceles triangle, at least 2 congruent sides, and they usually look like this, showing you this and this. They might show you this where they'll put 50 and 50. They might do this where they just show the angles. Well, when 2 angles are equal, so are the 2 sides. So the opposite sides are going to be equal as well. So those are isosceles triangles. Now it says at least, inferring that you could have more. Well, if you do have one more equal side, the better name for it is an equilateral triangle. So you always use the best names for things. So this is when all sides are congruent. And here's the different ways you'll see that. You'll have all 3 little markings. They might just decide to show you the angles are all equal, but if all the angles are equal, so are all the sides. And the last one is if I have all 60-degree angles, they add up to 180. That means the angles are equal, they're congruent. All right, so showing work on these. Now, obviously, I'm not going to see your work right now, so I would want you to show me that you are writing an equation and that it adds up to 180. I'm okay with you not showing me the addition and then subtracting it from the 180. You could just take your calculator. You could add the 2 of them up. You could say 17 plus 112, and then you could go 180 minus 129 and get your answer that way. You could put 180 and you could subtract the 112 and subtract the 17 and get it that way. That's up to you. You can just you're allowed to use a calculator on these, so that would be fine. Now you label your degrees with that little degree symbol, and then it says to classify it as acute, right, or obtuse. Well, if I look at the 3 angle measures, I see one of them is bigger than 90 degrees, so that one would be considered obtuse. So here I've got 62 plus 57 plus x equals 180. So if I take 180 minus 62 minus 57, I'm going to get 61 degrees. And because all three of these are smaller than 90, this one would be considered acute. All right, I've got 1, 2, 3. I've got 22 degrees. This one here doesn't have a number, but that square indicates that it is 90 degrees. And then plus x equals 180. If I take 180 minus 90 minus 22, I come up with 68 degrees. And because of the one right angle, it is a right triangle. Now these we're going to classify by angles and sides. So each one of these has to have two names. So one from here and one from here. So first I'm going to look at the angles, and I see that there's a right angle. So I'm going to call it a right triangle. And then I don't see any markings to show me that they're equal. So that would also be scalene. So you have to have two names for each one. First, by the angles, I see that I have one that's bigger than 90 degrees, so that one's going to be obtuse. And then I see that there's two that are equal to each other, or I could look at these two tick marks here, and when there's two, it's isosceles. Number 6, looking at the angles, they're all smaller than 90 degrees, so that would be acute. And then because it is all equal angles, it means it's also all equal sides, and that would be equilateral. You may hear of equiangular. Our book doesn't have that, but equiangular would also mean that it has equal angles. Lateral would be the sides. We use the word lateral for sides. Angular would be for the angles. So right now you're only responsible for those two right there. Okay? All right, so next you're going to be doing your practice. So back on this one, remember you're finding the x, so make sure you know how to write that as an equation, because in the next chapter, it's not just going to be x. You'll find multiple missing angles, and you might have a 3x or a 5x, and you have to find x and then find the missing angles. And then this one asks you to classify as acute, right, or obtuse. Down here, you have to make sure you have two names for each one. So when you look at the dashed triangles in each of these, you have to decide if it's acute, obtuse, or right, scalene, isosceles, or equilateral.